as if we met this assumption. So the first thing we want to do to interpret the linear regression is to look at the R-square value. The R-square value here is 0.173. So all of these predictors are listed here. So all of those predictors explain 17.3% of the variance in the dependent variable, which is behavioral precautions taken as a result about concern for crime. So that's how much variance we explain. So this is not a very large effect size for the model, all of the variables combined, but it is something to work with, and it is the relationships that are present in the data. So next we scroll down to the ANOVA box, and what we're looking for here is the probability value. The probability value here is indicated as 0.00, which really means less than 0.001. This is lower than our traditional alpha level. So we interpret this to mean that the model, the collection of predictors, significantly explains the change in the dependent variable, which is a step in the right direction. So our model explains 17.3% of the change in the dependent variable, and that is significant. So now that since our model is significant, we want to know how the model works. So we scroll down to the coefficients box to see how the individual predictors behave in the model and actually work to explain the dependent variable. So the first thing I want to look at is the probability values. So I look at this column here and I notice that all four predictors are significant. So all four variables contribute to the explanation of behavioral precautions taken as a result of concern about crime. That's first and foremost. Second, I want to look at the direction of all of those. So the directions are all positive. So as worry increases, behavioral precautions increases. As anxiety increases, as general anxiety increases, behavioral precautions increase. As age increases, behavioral precautions increase. And as concern increases, behavioral precautions increase. So now to determine the impact that each predictor has on the dependent variable, I move to the column labeled standardized coefficients, or the beta. And so here I notice that the largest value actually belongs to age. Every 1 standard deviation increase in age leads to a 0.216 standard deviation increase in behavioral precautions taken as a result of concern about crime. The next strongest predictor would be how concerned are you about crime in general? Next would be general anxiety, and then worry about crime. So those are our predictors in order of which does the most at impacting the relationship of behavioral precautions. Next, I want to look at the partial correlations, and notice that the partial correlations are very similar to the beta coefficients, and that the order in terms of strength roughly overlap. So age has the strongest partial correlation, then concern about crime in general, then general anxiety, then worry about crime. So if we wanted to assess each individual predictor's contribution to its explanation of the dependent variable, we could do that by looking at the partial correlation and squaring it. So for instance, if we look at how concerned are you about crime in general, we look at the partial correlation of 0.204 and we square that value, we'll come up with the value of 0.0416. So that means 4.16% of the change in the dependent variable is a result of concern about crime in general. On the other hand, age explains 5.01% of the change or the variability in the dependent variable, whereas worry about crime only explains roughly 2.5% of the change in the dependent variable. So both in terms of the partial correlation squared and the beta coefficient, age, then concern about crime, then general anxiety, then worry about crime are the best predictors. All are significant and all are positively related. So if you were checking for a hypothesis, increases in age lead to increases in behavioral precautions taken, then that hypothesis would be supported and the null would be rejected because of the probability value in this regression model.